Good morning, students. Once again, I welcome you to my video lectures on network analysis. In the last class, I explained what are the next topic is sources of electrical energy. Cell, battery, dynamo, genset. These are all sources of electrical energy. So, if you take any electrical energy source, there are two types of energy sources. There are two types of energy sources. Number one is what is known as independent sources and dependent sources. Independent and dependent sources of electrical energy are categorized under independent and dependent. Independent and dependent. First, I will take up independent sources, independent source of electrical energy. There are two realizations for independent. So, one is voltage source representation. Voltage, it is represented as voltage. It is represented as voltage. Voltage source. This is what is called as voltage source. And another way is a current source. Current source. So these are two realizations for independent energy sources. What is this voltage source? You connect resistance of any amount, any value, mega ohms, milli ohms, kilo ohms, any value you connect here. It is going to maintain this voltage V. So voltage V is going to be maintained. So this is what is called as source quantity. So source quantity is not going to depend on the value of resistance we connect here. So that is what is called as independent source, independent voltage source. But in real life we cannot experience this independent source. So first, idealized assumption is connecting any amount of resistance here, it is going to maintain a constant voltage V. Then it is said to be an independent voltage source. Next, so when it is supplying power, current comes out at positive terminal and current enters at negative terminal. Okay. But during charging process, for example, if this voltage source is put against a stronger voltage source, then there will be charging of the battery. So when charging means absorption of power. So when it is absorbing power, current enters here. Current enters here, current comes out here. But let us not bother about charging or discharging, but simply independent voltage source is represented like this. Next, independent current source. Independent current source is represented like this. Okay, so this is the arrow pointing in the direction of current. You connect resistance of any value here, any value. Okay, it doesn't matter. It is going to supply a constant current of I. So I is called as source quantity. So source quantity is not influenced by any factor. So that is an idealized assumption. So under idealized assumption, so I is the current, constant current supplied. Then this is said to be an independent voltage source, independent current source. To continue with sources of electrical energy, after understanding independent sources of energy, next is dependent sources. Dependent sources are also called as controlled sources. So here the source quantity, in the case of independent sources, the source quantity was not influenced by any factor. But in the case of dependent sources or controlled sources, the source quantity is being influenced by an external factor. Now, dependent sources or controlled sources are 4 in number. They are 4 in number. Number one, current controlled current source. Current controlled current source. Current controlled current source. This is first one. The second one is voltage controlled current source. Voltage controlled current source. Next, voltage controlled voltage source. Voltage controlled voltage source. And lastly, current controlled voltage source. Voltage source. So four types of dependent sources: current controlled current source, voltage controlled voltage source, and lastly current controlled voltage source. Now we shall take up these one by one. First, this is the notation. First one, current controlled current source. KIX. Now, independent sources are represented by circle symbol. But while representing the dependent sources or control sources, we have to use diamond symbol. So here, this is what is called as source quantity. Source quantity means the value of this source, KIX. So as this is a current source, and that is why there is an arrow here. Arrow stands for direction of current it is supplied. So KIX, K is a constant and IX is current elsewhere in the circuit. And KIX is a factor that is going to control this source quantity, this current value. Hence it is called as current controlled current source. I don't know whether you catch my point or not. I will give the example of a transistor. In the case of a transistor, for example, take NPN transistor. So as there are three currents, base current, collector current, and emitter current. These are the three currents. The current on the collector side, that is output side, IC, is a function of base current. So IC current is decided by base current. So there is an influence of base current on collector current. It is like this. So influence of IB on IC. So that is what current controlled current source. Okay. Current controlled current source. This is first one. Second one is voltage controlled current source. So same current source, but here voltage controlled GVX. So Vx is a voltage elsewhere in the circuit. It is influencing this value GVX. So G is a constant. So GVX. So Vx is influencing this, and hence it is called as voltage controlled current source. Next, voltage controlled voltage source. In the case of op amps, we come across this type of dependent source. In representing the equivalent circuit of an op amp, we require what is called as voltage controlled voltage source. Voltage controlled voltage source. As it is voltage source, mark here plus minus, and it is written here KVX. Vx is a voltage elsewhere in the circuit. It is influencing this value. So K is a constant, KVX. If you remember, op amp, operational amplifier, to write the equivalent circuit of op amp. So this is the equivalent circuit of op amp. This is what is called as input resistance. This is what is called as input resistance of op amp. This is non-inverting end, this is inverting end, and here we write a dependent source, voltage controlled voltage source. So that is VI. VI is input voltage. So this is KVI. KVI, and this is output resistance. This is output resistance. And here this is what is called as equivalent circuit of op amp. So in the equivalent circuit of op amp, here KVI stands for voltage controlled voltage source. Voltage controlled voltage source means this voltage VI is going to control this value, K is a constant. So this is what is called as voltage controlled voltage source. Lastly, current controlled voltage source. Current controlled voltage source is represented by current controlled voltage source. These are all standard notations, okay? Standard notation. RIX. IX means current elsewhere in the circuit. R is a constant. So RIX is the source quantity. So for example, if IX decreases, then RIX also decreases. If IX increases elsewhere in the circuit, it is going to increase this value. Hence, this source, this type of source is what is known as current controlled voltage source. So in network analysis, we come across these dependent sources, these types of dependent sources, and in the next class, I will continue with real sources, reality. So we made idealized assumptions in defining independent sources. Now coming to reality, in the next class we shall take up what is known as practical sources. Thank you.